Hello, Algebra 2 class. For today, we're going to go over the summation notation using the Greek symbol sigma, as you see right here. And I'm going to go over how to deal with these types of questions when you see them on your quiz for today. Same as before, it will be due by tomorrow, 12 p.m. You will see questions like these, and you will also see questions like where we have been doing for the past couple of days, where I give you the last term and the common difference and the end, and you have to look for either the first term or some components dealing with the summation the series. One of the components will be missing, and you have to look for that first. Okay. All right. So first, the summation notation. I need you guys to take your notes on this. Is that once you have this Greek symbol called sigma, this is a notation that is used, commonly known as the sum of the function. You will always see on the bottom something like, let's say, k is equal to 1, I is equal to 1, or x is equal to 1, something. That should tell you where your starting value would be, or your first value, the first term. And then this is where it's always going to end. So hence they say it's a first and last value of k. The k represents the term, not the number, like not the number in the sequence, like 1, 3, 5, 7, 9. It doesn't mean these numbers. It means 1, 2, 3, 4, 5. The third term of the sequence, the fourth term of the sequence. That's where you're starting and that's when you're ending. The function in this particular case called 3i, that is your formula for the terms in the series. In other words, this is your explicit formula or your recursive formula. It was something that you have to reuse over and over again to find out what exactly is within those within the sequence. So for example, I gave you this little chart here to help you understand how to get each of those numbers. You will see that my I value will start at 1 and go all the way to 6. So 2, 3, 4, 5, 6, all those terms. This is asking you to add the first 6 terms from 1 through 6. So that's 6 terms in total. So what are we going to do with these I values? That you're simply going to plug it in the formula. So 1 times 3 is 3. 2 times 3 is 6, 9, 12, 15, 18. You get the idea. Now, what are we going to do with all of these numbers here is that you're going to add them. 3 plus 6 plus 9 plus 12 plus 15 plus 18 is the answer to our original question, sigma 3i from 1 through 6. That's simply going to be, well, that's 9, 18, that's 30, 45, that's 63. Okay, so try doing this question. I have from 4 through 18. Now, it will be kind of ridiculous as the numbers increasingly get more difficult or in more tedious ways, that if there's more numbers in between, you don't want to find out all of these numbers and add them up, because that would be stupid and time consuming and pointless, and it's tedious. So let's use the formula that we're all given. Okay, remember, you always need 3 things: the first term, the last term, and the number of terms within them. It will be hard for us to kind of understand what n value is in this particular case, but it's easy for us to find out the first and last term, right? Now notice that the first term is a sub 4 and the last term is a sub 18. How do I figure that out? Well, just plug it in. 4 times 6 is 24, minus 1 is 23. 18 times 6 is 108, minus 1, which would be 107. Okay, so that first you need to establish your first and your last value by plugging those values in. Those are the only ones you're going to plug them in. Now I need to find the value of n. Well, is the value of n just 18 minus 4? Unfortunately, is not. So that's 14 numbers, right? But if you were to actually count these numbers, guys, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15. So you're adding actually 15 numbers in total. Well, why is that? Well, if you were to count from 1 through 10, you cannot tell me that that's 9 numbers in total, because that's 10 minus 1. If you were to literally count from 1 through 10, that's actually 10 numbers in total. So the way to do this is that the highest n value minus the lowest n value, and you have to always add the 1 to it to find out the total number of terms. So you do 18 minus 4, because sometimes you're going to be starting at a term where it's not going to be 1 all the time. And then you always have to add 1 to it at the end of the day. So your final number here would be 15 numbers in total. Then let's plug all those components in there. 15 divided by 2 times 23 plus 107. That's exactly what we're going to do. So 107 plus 23 times 15 divided by 2 gives me my final answer to be 975. Okay, so this total sum of the 4th term to the 18th term would be 975. This is what you're going to say. Okay, and now what I would like you guys to do is pause the video, and if you'd like to draw the chart, that's fine, but I would like you to find out the first term of the sequence, which is the 9th term, the last term of the sequence, which is 21, and I would like you to find the sum. Remember, you need to find out the total n value between 9 through 21, and I hope you realize it's 21 minus 9 plus 1. Don't forget to add the plus 1 at the very, very end. Okay? Pause the video and play it again once you have all the answers. Okay, so once you plug in 9 to the m, you should get 45 plus 6, which is 51. A sub 21 means 21 times 5, which is 105, plus 6, which is 111. So that's my first and that's my last term of the sequence. The sum of 21 numbers is n divided by 2 times 51 plus 111, the first and the last term combined. The n number is 21 minus 9 plus 1, which would be 12 plus 1, which would be 13 numbers. So n here, I would replace it with 13. So 51 plus 111 times 13 divided by 2. My final answer here will be 1053. Okay. All right, let's do 2 more examples, just like that one. So find the sum of each arithmetic series. Now, I'm not going to give you to specifically find a sub 5, a sub 16, because that's my first and the last term of the sequence, and also find the n value. But that is what you should be doing for both of these questions, and then find the summation of the summation of those numbers. It's not the first 16 numbers. That's not how we should write it. We should just write the sum here and then sum here. A sub 0, a sub 12, and then n value. Okay. All right. So I'll again pause the video and make sure you have these questions written down on your notes, and then try it on your own, and then we'll verify the answers together. Okay, a sub 5 should be 16. A sub 16 should be, if I plug it in, that should give you 32, 38, I believe. Yes, and then the n value here would be 12. 16 minus 5 is 11, plus 1 is 12. So once I plug it in, it will be 12 divided by 2 times 16 plus 38. That will be the answer. So my final answer here would be 324. Hope you guys all have that. A sub 0 here would be 2. A sub 12 would be negative 34. The total numbers between 0 and 12 will be 12 minus 0 plus 1, which is 13. Not 12, 13 numbers. The summation would be 13 divided by 2 times 2 minus 34. So 2 minus 34 is negative 32. Divided by 2 times 13 gives you negative 208. So that will be the sum of all the numbers from 12 to 0. Okay, hope this video helped. Your quiz will contain questions like this with the sigma notations, along with several other questions that we dealt 2 days ago. Okay, that's due tomorrow 12 p.m. Make sure you have it done by that time, and have a good weekend. Thank you, and have a good day.